And I could have done it this way, I think, to start with, but then its connection to the complex numbers would have always kind of been a mystery. So here's another way to see the relationship that Q of t, which is this piece right here, that Q of t is in fact the cosine of omega t minus phi. So I can show you another way you could have gotten that without the complex numbers. But we need the complex numbers, that's why we took that route. So you can prove it two different ways. There's one. The other way would be this. So let's try this. Cosine of omega t minus phi is equal to, so here's what we have to do. You have to remember a trig identity. Does someone by chance remember the cosine of a difference of angles? I know. This is why we took that route. I'll help you with it. It's not one that I think most of us easily remember. You'll probably remember once I start writing. It's the cosine of omega t times the cosine of phi plus the sine of omega t times the sine of phi. Okay? And then we said, well, wait a minute. This has got to equal, somehow all of that has to equal this Q of t. So let's write this out and compare. So if I have a cosine of omega t plus b sine of omega t equals, I'm going to write out this right-hand side again, a cosine omega t cosine phi plus, I'm going to just I don't want to ruin my picture quite yet, plus the sine of omega t sine of phi. So now what we do is something, a technique we've used before. Again, like in partial fractions, you're comparing. Notice this. Here's cosine of omega t. So in order for this identity to be true, which we already said it is, I mean, we proved that these two are the same, and we also know that these are the same, so what we're curious is the relationship between Q of t and this expansion here. Well, what this expansion here tells us is for this to be true, that this implies, I'm going to use an arrow. That's an arrow like that in math is red. This implies this implies that A has to equal, oh gosh darn, I forgot something. What did I forget? Yes, I forgot R. You guys should have said something. Let me put R into this. R. Thank you. R. 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 There. Yeah.
How did we start with R cosine of
Oh, that was from over here.
So how did you start with that previously?
You wouldn't know. We did all of that to get to here. And now I'm showing you another connection. That's it.
There's two.
Yeah, there is. So there's the first method is we said, oh look, Q of t can be written as this. And we got there using complex numbers. And now what we're going to do is we're going to start here and we're going to use a trig identity to see this relationship and see if it still holds the other way. Good question. So let's come back over here. This implies, I'm going to just write this. This implies arrow. So what do I have? I have that A has got to equal R times cosine of phi. And if I match up my other term, here's my sine of omega t, sine of omega t. So in order for this equality to hold, then B has to equal R sine phi. And if I'm not mistaken, that should be somewhere else on this board. Is that a relationship we already got? Oh yeah, right here. Or you could write it from down here. All right, so that's where that's the other connection that you can see. So you can go both ways with it. Okay, I'm going to erase some stuff. Do you want me to go try putting all this together? I'm not sure if I am. I thought I was. I don't think I am. So hopefully you have pencil. Let's see what we can say. So here's how the process works. Let's go back to our opening. Our opening goal was to solve. So let's go. So now we're back to solving. And what were we solving? We're solving y prime minus y equals a sine, no, cosine cosine omega t plus b sine omega t. Okay. Now the first thing that we can do is this. We said that we can write this now as R times the cosine of omega t minus b. Okay, I'm just using our identity there. Just using the identity. And notice, what is this? Oh, let's go do a quick review. What is R? Yeah, they call it the modulus. That little line, this line that I just erased is modulus. Probably forgot to tell you that. But now you have it.
Is that maybe the modulus in the imaginary element?
Say it again?
Is it probably the modulus in the imaginary element?
Yes, the complex one. But R is correct. It's the square root of a squared plus b squared. Okay, and we know that phi comes from what? Yes, it's the angle, and we called the angle was tangent of phi equals b over a. Okay, so that's the connection between this and this. R is the square root of a squared plus b squared, and the tangent of phi is b over a. Okay, so that's the connection to go from here to here. Now we go one more step. we solve the complex equation. Now, I'm going to write that up above, just getting kind of out of sight for most of you. So solve the complex equation like this. Z prime minus a z equals k. But this piece right here is the real component of that exponential form that we said was capital R e to the I parentheses omega t minus 2. Big step, huh? So now we're going from this step to this step. We're thinking all in the complex numbers now. And we said, well, this is just the real component of that complex number. So, and in the end, we're going to go back and grab our real solution and pull it back out. That's our end goal. So how do we do this? Let's do this. Find y particular equal, your author sometimes uses a capital Y and sometimes uses a capital Z. I'm going to use them kind of interchangeably. I'm going to call it Z particular. So this is a lowercase z as a solution equals, I'm going to use a capital Z. Now you know what, let's use capital Y for clarity. Capital Y e to the I times omega t minus. So what we're saying is our general, this is going back to the way we solved exponentials, where we said the solution is going to have something in this form. What we don't know is what the multiplier is. And this is exactly the same idea as when we remember when we tried to solve, when we had q of t was e to the ct, and we said, oh, it's going to have to be an exponential of, it's just figuring out what this number is. It's the same, we're in the same spot again. So what we can do is, let's figure out what y has to be, okay? So we're going to need z particular, so let's find that. And then we'll substitute it in here and we'll see what we can, and we'll find y. So z particular prime is going to be y times e to the I parenthesis omega t minus p parentheses. And then we apply the chain rule. And notice this is I omega t minus I phi. So when we take the derivative of the exponent here, and we apply the chain rule, I and phi, that's just a constant, so that's going to be 0. And so we're going to get the derivative of I omega t is going to give us an I omega. Derivatives work in complex numbers just like you would expect. Now let's substitute. Yes? Complexifying.
Is this like, I mean, obviously we know that in the end this will work, but
yes.
Will this only work like sometimes? So like if you were to attempt this on this like any differential equation, is it kind of like, will it like sometimes work, sometimes not work?
It works for anyone that's sinusoidal.
Okay.
It works for sinusoidal. Doesn't work for all.
What would you expect that to turn into if it wasn't going back? What would you say?
What do you mean? What do you mean, try? What strategy would you use?
No, or just like, say you applied this method on one that wasn't loaded in the hanging out for that problem. It's
Oh.
like, you just stop, it's like completely.
Yeah, I think, if I understand your question correctly, if you tried this approach on a problem where this approach isn't going to work, you'd run into some really weird dead end that doesn't make sense. The math would come up with something that doesn't add up. And you'd be like, oh wait, I just have to stop and start over. I know, that's not a very good answer, and honestly, that's one of the difficulties of the subject, there isn't one way to solve all problems. So in our next section, we're going to take a look at exact equations, and then I'll introduce another thing to ponder and figure out, and then we're going to talk about second order equations, and then that'll add another dimension to solving these. So one of the big difficulties of differential equations is learning and how to apply all these different tools that we're going to put in your toolbox. So that's a good question. It's a loaded one. That's why we're here for a whole semester. Yeah, good. Let's solve this. So we have z particular, we have z prime, z particular prime. So what we're going to do is we're going to put these two values back into our original equation, and we're going to see if we can find y. So let's do that. So z prime is I omega